Students, in chapter electrolysis, we will do now some examples of electrolysis. Electrolysis of molten lead bromide. Molten lead bromide. Solid lead bromide cannot conduct electricity. Electrolyte. What is electrolyte in this case? Molten lead bromide. Don't miss this word molten. Formula and name both you have to learn. Above 380 degrees Celsius, melting point of lead bromide. Lead bromide have a melting point of 380 degree, and this melting point is maintained with the help of burner. Here you see burner is there, burner, and what happens in this case? This is a silica crucible, silica vessel in which molten lead bromide is placed having melting point 380, and this melting point is maintained by burner, and two electrodes are there. Anode is made up of graphite and cathode is also made up of graphite, right? And here you can see connection is given to negative terminal means cathode, positive terminal means anode. Electrolytic cell, it is made up of silica, and question arises why it is made up of silica. Because silica can withstand very high temperature. It is already given here, you see. Because silica can withstand very high temperature and is almost non-conductor of electricity. That is why silica crucible is used. So vessel used, electrolytic cell, silica. Why it is used? Because it can withstand high temperature and is non-conductor of electricity. Electrodes, already we have seen that cathode and anode both are made up of graphite only, which are inert electrodes. What is ionization dissociation here? Lead bromide, actually they have not written, I will show you. This is lead bromide. It undergo dissociation to form lead ion and bromide ion. Lead ion and bromide ion. You have to learn these ion with valency. If valency is wrong, you will not get marks. And lead ion is the positive ion, bromide ion is the negative ion. And you know that positive ion, they migrate towards negative electrode, that is cathode. Cathode is negative electrode. So lead ion reach there, stick with the cathode, then cathode donate 2 electrons to lead ion. Why 2 electron? Whatever is the charge on the ion plus 2 means it has deficiency of 2 electron. And if ion have a deficiency, it will gain electron from cathode, gain 2 electrons from cathode, and that deficiency is overcome. Neutral atom is formed which is silvery gray in color. What is the color of lead? Molten lead. Molten lead is formed. What is the color of molten lead? Silvery gray color is there. And bromide ion migrate towards the positive electrode, that is anode, and because it has charge -1, so that means 1 extra electron, so it will lose 1 electron. Negative ion lose electron. How many? Whatever are present, whatever is the charge on them. Negative charge is 1, so 1 electron it will lose to form Br. And because bromine is a non-metal, so it cannot exist in atomic form. 1 Br combined with another to form Br2, and because temperature is high, so bromine have a red color, and therefore red vapors of bromine are seen. This is silvery gray, molten silvery gray metal is formed at cathode, and at anode red vapors of bromine are formed. And bromine is a halogen. Halogens are very reactive, right? It's a halogen and halogens are very reactive, and that is why anode, because halogens, any halogen, whether bromine or chlorine, they are very reactive, and in vapor form they are even more reactive, and that is why they attack all metals like platinum. Okay, they will attack all metals like platinum. right? And therefore a node will be spoiled. And that is why a node is made up of graphite, because bromine cannot attack or cannot react with graphite. So reason is given here why a node is made up of graphite. Now what is the overall reaction? What is the overall reaction in this case? Molten lead bromide decompose in electrolysis to form lead metal, molten lead, grey, silvery grey metal, and red vapors of bromine are formed. Right? Now what is the observation? Already I have told you, reddish brown fumes of bromine are evolved at anode, red vapor, even you can write red vapor also, and a silvery grey metal is formed at cathode, molten state. Clear? So this is your electrolysis of molten lead. And why silica is taken, I have already informed you. Next is why solid lead bromide is not taken. Molten lead bromide is taken. Because in solid lead bromide, ions are not free. Why they are not free? Because lead bromide is ionic compound, and ions are held by strong electrostatic force of attraction. That is why ions are not free. So no free ions. That thing, that is absence of free ions or no free ions, that makes it bad conductor, non-conductor. That's why we cannot take it. And why then molten lead bromide is taken? Because when lead bromide is heated, right, then the electrostatic force of attraction between lead and bromide ion is overcome, and ion become free, right? And when ions become free, then molten lead bromide conduct electric current. So this was electrolysis of molten lead bromide. Now next is electrolysis of water, acidified water. Right? Electrolysis of acidified water using platinum electrode. What is the electrolyte? Acidified water means water and dilute sulfuric acid. Now question arises, why, first though one question is why acid is added? Why acid is added? Because water is a poor conductor of electricity, and acid, when you put acid, it ionize and furnish large concentration of ions, which make water good conductor of electricity. Right? To means it increases the conductivity of water. Second, why only sulfuric acid is added? Reason, because other common acids are dilute nitric acid and HCl. They are a highly volatile acid, means they changes into gaseous form very easily. Volatile acid, while sulfuric acid is non-volatile acid, and non-volatile acid only can be used. Right? So why sulfuric acid is used instead of nitric acid and hydrochloric acid? Answer is given here. Now electrodes. What are the electrode? Platinum. Okay, platinum electrodes are taken. We can take platinum foils or rods and connected naturally. See, connection wire, these wire, they are always made up of copper. Connecting wires are made up of copper only. Right? So here also connecting wires are made up of copper only, but electrode is platinum. Platinum electrode, both anode and cathode are platinum. Ionization, I've already told you, in pure state water consists of almost ions only, molecules only. Only molecules are there because it is polar covalent compound. Right? So very few ions are there. One ion is there out of 2 million, 20 lakh molecules. One molecule change into ions. Right? So poor electrolyte. That is why acid is added. A dilute sulfuric acid catalyzes the reaction, hence electrolysis of acidified water is considered as example of catalysis also. And I'll show you afterwards why sulfuric acid is a catalyst here. Now see the diagram. Here, from here we can add acidified water, and this middle arrangement is connected with two side cylinders. In one cylinder, cathode wire, a platinum wire is there, which is connected to negative terminal of the battery, that is cathode. In the another cylinder, there is another platinum wire which is connected to positive terminal of the battery, that is anode. Positive and negative terminals are there, and in the beginning these two cylinders are fully filled with water up to the top. Then electrolysis takes place, means electricity is passed. Then what we see, bubbles are seen at the electrodes and gas is collected here and the water level keep on moving down. That means gas is collected here in the empty space, right? Now ionization in case of water. Water ionized to form H ion and OH ion. See what is there in acidified water? Acid is there, water is there. So this is ionization of water. Now acid is also there. So sulfuric acid ionized to form 2 H ion and sulfate ion. So positive ion is H ion, negative ion are 2 OH and sulfate ion. And because what are the ions present now? H ion is there, positive ion, 2 negative ion, OH ion and sulfate ion. Right? 2 negative ions are present there. Right? Now see that what are the particles present? All ions, all 3, plus water molecule. So molecule is also particle, ions are also particle, but here only ions are there, here plus 1 molecule also. And you know, H ion or positive ion, they will migrate towards cathode, right? And because H ion have 1 unit positive charge on it, deficiency of 1 electron, gain 1 electron to form neutral H atom. And because hydrogen is a non-metal, so it will combine with another hydrogen atom to form hydrogen gas at cathode, right? Now reaction at anode, sulfate and OH ion migrate towards anode, and because OH ion comes lower in the electronegative series, see this series, sulfate ion is here, OH ion is there on page number 108. So because OH ion is lower in the electrochemical series, so OH ion will lose 1 electron, OH minus 1 lose 1 electron, right? 1 break to form OH and 1 electron is lost. So this OH radical is formed. These type of 4 OH radicals, see here they have shown 2 OH, 1 OH plus 1 OH react to form 1 water and 1 O, and 1 O comes from 2 OH. We need 2 O, right? So 2 O combined to form O2. That means in place of these equation, you can directly, this also altogether, you understand from here, but in the examination you directly write 4 OH. 1 OH loses 1 electron, 4 OH will lose 4 electron to form 4 OH radical 1, and these 4 OH recombine to form 2 water and oxygen. In place of so many equations, you can write these two. Clear? Now this is over. So what is the gas formed at anode? Oxygen. What is the gas formed at cathode? Hydrogen, right? Oxygen and hydrogen. Hydrogen is formed at cathode, oxygen is formed at anode. Now note, very important one. Since sulfate ion, negative ion, they also migrate towards anode. Sulfate ion are around anode because they migrate towards anode. And H ion have been discharged at cathode. At cathode, H ion are discharged. Discharged means H ion gain electron to form neutral hydrogen gas. So if any positive and negative ion gain or lose electron to form neutral atom, we call it discharge. So H ion discharge means there is deficiency of H ion around cathode. But sulfate ion migrate towards anode means there is a deficiency of sulfate also at cathode. At cathode, H ion discharge means finish. Okay, in a way finish because it changes into hydrogen gas. And sulfate ion migrate towards anode. So at cathode there is a deficiency of H ion also and sulfate ion also. H and sulfate together is sulfuric acid, and that is why sulfuric acid, concentration of sulfuric acid decreases at cathode. So this is the reason why concentration of sulfuric acid is less or decreases at cathode. Now come to anode. At anode what happen? OH ion, one OH ion, okay, it discharge of OH ion, already we have discussed. OH ion are discharged. That means OH ion decreases. When one OH ion decreases, right? See, one OH ion decreases, that disturbs the equilibrium between molecules and ions, right? Because of this disturbance of equilibrium between molecule and ions, one more water molecule at the same time ionize to form hydrogen and OH ion. See, there is always equilibrium between ions and molecules in case of water, or in case of any ionic compound, any other compound. There is equilibrium, balance between number of H and negative and positive ion and molecule. If ions are ions are used up, ions are changed into some neutral atom, like in case of discharge of OH ion, OH ion changes into OH neutral part, neutral radical. So then there is the equilibrium between H and OH ion is disturbed. To maintain this equilibrium, one molecule of water change into ions, H and OH ions. So that equilibrium is then again maintained. Right? Now excess of H ions are there, thus produced because of this ionization of water, and sulfate ions are already at around a node, because negative ion sulfate ions, they migrate towards a node. And now H ions are also present, because H ions are formed by decomposition of water, ionization of water. So H ions are present and sulfate ions are around a node. So around a node, H ion is also there, sulfate ion is also there. H and sulfate ion means sulfuric acid altogether. So that this increases the concentration of sulfuric acid at anode. Right? So concentration of sulfuric acid decreases at cathode but increases at anode. Right? That means sulfuric acid does not take part in the reaction. At one place its concentration increases, one place it decreases. Overall it is not affected, and that is why it is called electrolysis of water is called catalysis. Because what is catalyst? It increases the rate of the reaction but itself does not take part in the chemical reaction. Right? Now another thing you have to understand, and what is that? Carefully you understand this. What is this? See, if you see, this is water. Water ionized to form H ion and OH ion. H ion and OH ion. And we know 4 OH ion, already we have discussed, break to form 2 water and oxygen. Only this OH ion, 4 OH ion break to form 2 water, combine to form 2 water and oxygen. Clear? On the other hand, if 4 OH we have to use in this reaction, right, that means 4 H ion also should be there. Why? Because 1 water form 1 H and 1 OH. To get 4 OH ions, there should be 4 water molecules. See, 1 water decomposed to give 1 H ion and 1 OH ion. 4 water will give 4 H ion and 4 OH ions. Right? And these 4 OH ion form 2 water and oxygen to complete the molecular equation. Then how many H ions are there? 4 H ion. And what 4 H ion will give? 2 hydrogen molecules. Right? So hydrogen molecules are 2 and oxygen molecule is 1, and according to Avogadro, molecules are equivalent to volume also. So 2 volumes of hydrogen is there and 1 volume of oxygen is formed in the reaction. So this is what is discussed here in this part, ratio of hydrogen to oxygen. Right? So see, I am showing here, you just always discuss this equation. No need to do a long thing. Very long topic is there. That's not required. Clear? So this was electrolysis of water.